Hello guys, I want to show you how to create shaders, learn what is the shaders. Okay, first I want to teach you something about shader structures. You can create shaders from here. Complete. Surface. We have two main shader types. Fragment shaders without lighting implementation, surface shader with Unity lighting implementation. Okay, we have two options to create shaders. First, fragment shaders. Second, surface shaders. Surface shaders is the same as fragment shaders. This is a automatic language to create fragment shaders with lighting implementation. Okay, we just want to speak about surface shaders. This is the very easy, very powerful, based on Unity own lighting model. Very powerful, very easy. Fragment shaders, so hard. You must write lighting implementation. Okay. After creating a simple surface shader, you must learn first what is the shader structure. First part is properties. The first part is shader name. For example, my shader my first surface shader. Diffuse shader. Now you can create a new material. My test material. Assign your shader from here. My shader, my first diffuse. For example, I remove this. My shader diffuse. My shader diffuse. Okay. First part is shader name or shader path. Second part is about public properties. For example, we have my color, the name, my first color, the type color, the value. value is RGBA alpha. Now you can see your color. My first color. Change its name. Default value. We must change to see default value. Okay, another variable is my variable, the name, intensity, the type, float, default value 1. Intensity default value 1. You can use range instead of float, range 0, 1. Now you can see your slider. Another type, important type, is my texture, diffuse, the type is 2D texture, the value is white. Or you have my normal map, normal type 2D, and default value bump. Now we have two new public variables, diffuse, normal. If you have a normal map, for texture, in standard shaders we have an option. We have options to convert textures to normal map. Here, normal map. Where is my shader? Okay, my shader. We don't see fix it button here. How to add this? Just select this header, normal. Okay, just add normal before your normal map, and to see this button automatically change the type to normal map. Okay, another type, if you want to change position, just change position here. You can see position has been updated. Okay, this is the most important part, variable types. Variables type. First one is float or range. Second, diffuse map, and second one is bump, color and bump map. We have four important shader variable type: color, range. 2D. Or bump as a normal map. And we have color float. 2D white or normal map. These are most important variables type. So here we can assign or add public variables. Okay, this is the public properties. Here is your main shader body, or I just want to, for example, you have test class. You have test class here is your class body, and here is your shader body. Shader body, class body. Your class has update function, your shader has update function, or pixel shader or surface shader. Here is your update body. Okay, we can assign public variables. Public color, my color. You can see same thing here. Properties, public properties. These variables will be shown in this inspector, and these variables will be shown here. Shader inspector, in shader inspector, in this shader inspector. Okay, here is your shader render types. For example, in standard shader you have opaque, cutout, alpha, transparent. You can change render type to transparent or opaque. Okay, here is level of details is not important. This is a shader keyword. This is a shader settings. Type is surface shader. Surface shader function name here. Lighting model standard. You can use Lambert or Fong. For standard shader. Standard lighting model is Unity 5 PBR lighting model. Full forward shadows. Here is your shader target model. For example, OpenGL ES2 .0 or shader 3, or the default is 3.0. Okay, here is shader input instructor is not important. All all the public variables or properties should be redefined here. For example, we have my variable. You should here write float my variable. You have my texture sampler 2D my texture. Sampler 2D my texture, my color, and my color should be fixed 4 or RGBA. My color, normal map is sampler 2D normal map. Here you can modify properties from inspector. Here we have redefined variables to use in shader body. You cannot use these variables directly in your surface shader. You must redefine all public properties or variables here to you can use it's here. You can use them here. Okay, this is, I don't know what is this. It's added by GPU instanting. It's not important, you can remove for all shaders. So the main shader body is here, surface shader or public function. Here we have input in or this input to get access to texture UV, and output as a surface output standard lighting model. Here you assign it standard shader. Okay, I want to show you a legacy shader. Diffuse. Legacy shader. I want to show you some legacy shader. Diffuse. You can see public properties. This is a mobile diffuse. You can see public variables, main text, base RGBA. Here is its name, RGBA. You can't see any color or float properties here. The shader type, surface, render type, opaque, surface function here, the main function. The lighting model is Lambert. Lambert is a very simple and basic lighting model without any specularity or shyness. This is the most cheap lighting model for low-end devices. Lambert just use direct lighting and shadows, no forward add. I don't know what is this. Okay, here we redefine public properties to use in shader body. So this is and this is the input to get access to main text UV to apply it to the main texture. Here is input in to get access to here. This is the surface output. Here in standard shaders, standard PBR lighting models, you must write this one and assign it here. In legacy shaders, optimized mobile shaders, you must write Lambert or Bling font. Lambert is most cheap, and write the shader output this one. Okay, to start working, we just need to return albedo values, alpha values, and normal values, normal value, that specular, that emissive. No, this is not true. I don't know. This is Lambert lighting model outputs. In standard shader lighting model we have output as a metallic, a smoothness, alpha, albedo, normal map, occlusion, and so on. Let's okay. Grentel introduction to shaders. 3D model, vertex texture, anatomy. Here's the public, subshader, shader body, the properties, public properties. As you can see in shader inspector, redefine public properties, rendering order, render type opaque, Q geometry, CG program. Here's shader body, shader type, surface, main function, lighting model, UV. Here's albedo without specularity, smoothness, reflections, the vertex and fragment shaders. This is a vertex shader or fragment shader type. We had surface shader and fragment shader or legacy. It's hard, easy lighting, you must write lighting calculation. This is the fragment mode, fragment type of the shader. Fragment type is too similar to surface shader, but you need both vertex output and fragment output. It's a bit hard and it's not as you can see, we have not any lighting model. This is a simple surface shader, it is shorter and have very cool results. This is a fragment shader with fragment here. This is a fragment shader with line code and without lighting implementation. So Grentel introduction, lighting overview, lighting, rendering and shading, lighting overview, shader programming. Here. No. Shader programming. Shader programming, part 2, surface shader. Okay.